Shout to Automate team welcomes you to a short video presentation of the minimal viable product, the service modeling. The core of the system revolves around a strong CMDB and a service model capability. There are several pedal services that are offered on top of the service model, like alarms, actions, service glass, and configuration comparator. We will directly jump into the demo. Upon successful login, the user will be presented with the dashboard of the tool. The dashboard contains 4 major widgets. Let us start from the left-hand top corner where we have a carousel for service selection. Upon selecting a service, all the widgets are set to the context of the selected service. Let us move down and see the second widget on the left-hand side bottom. This is the widget that helps us manage all the required actions of the CIs. All configuration items that are part of the service are shown here. For example, the load balancer, Tomcat, DB, backend box that are part of the inventory management system are shown here. Now let us choose the Tomcat CI to look into the different Tomcat instances that are available as a part of this service. In this case, there are 4. Upon selecting a particular instance, all the properties of the Tomcat are shown. The user can also edit these properties if required. Now let us move to show how the user can add a new CI. For this demo, we will add a new Tomcat server to the existing service model. Upon clicking on the plus symbol on the widget, a wizard will help complete the process of addition. The user gives the details of the CI and also the relationship of the new CI with that of the existing CIs in the service model. Now you can see that the service model is updated with the new CI that we added. This takes us to the core functionality of the system, service modeling. This service model is dynamically vectored around the CMDB. CIs are positioned and linked based on relationship which they share with the others in the ecosystem. This dynamic service model is powered by D3.js. Let us take a few seconds to understand this particular model. Now we will take a look at few key table structures from the CMDB. This forms the base of the service model. The service model starts with a service on the top, the load balancer of the service. The load balancer of the service then connects or serves to 4 Tomcat instances, and they have their connections with the backend boxes which run few job schedulers, and also they are connected to the respective DBs. Now to understand the impact analysis, we have to understand the weightage of relationships and how it is set up. To do this, we will click on the balance weightage option on the right hand side of the service modeling widget. There are 3 classifications in which children are balanced with respect to their parent. First one, independent. Independent weightage classification will make every child of its parent as critical, meaning any of the children gets impacted, the system considers the parent also to be impacted. Second one, equal weightage. The equal weightage classification will consider every child of its parent to be having equal weightage, meaning all children should be impacted to make the parent impacted. Third one, custom weightage. The user is presented with all possible combinations of the parent and its children. The user can choose a group configuration from below that depicts the weightage of relationship this CI has with its children in the best possible way. In this case, let us choose the second configuration, that is 3 Tomcats form a group and the 4th one is an independent Tomcat server. Several actions can be taken by clicking on individual CIs. Let us click on Tomcat 4. This gives us the status of the Tomcat server, the status of the host that it runs on, and also the actions that can be performed on the Tomcat server and the host. In this configuration, if Tomcat 4 gets impacted, the service will become critical and inaccessible. Let us explore the other group now. To do that, let me start the Tomcat server of 4 to ensure the service is back in action. Now let us assume that Tomcat 3 goes down. We will see that the service is still up and running as Tomcat 3 is not a single point of failure for this service. Still, the other 2 Tomcat nodes can share the load and provide the required functionality. Let us make Tomcat 2 also down. Even now, the service is serviced by Tomcat 1. Now, finally, we will make Tomcat 1 also down. This will make the service inaccessible. Similarly, when we have any one of the Tomcat services up, the service resumes. This summarizes the service modeling, weightage of relationship, and the impact analysis simulation. In real life, we will integrate it with AlarmDB, and the service impact will be based on alarms received, and the actions can be taken based on the current state of the CIs. This brings us to the last two pedal services of this offering, Service Glass. Using the camera icon, we can take a snapshot of the entire service model, meaning all the CIs and their corresponding properties and their values at a point in time. This feature is very useful to understand the trend of degradation and helps in multi-people troubleshooting exercise. We will move to the configuration comparator. Let us click on the eye icon to invoke the configuration comparator. This will help us compare any two snapshot that was taken using the service glass. It will highlight the anomalies and trends for very effective troubleshooting. This completes the demo. You can try our beta offering at s2a8.com. Please write to us at shout2automate@cineverse.com for login credentials. Thank you for watching.